Hello everyone, welcome back to another video. Today we'll be talking about objects. Now before we start talking about objects, let's say we want to have a scenario where we're keeping track of multiple things at once. So maybe we're keeping track of student data. Maybe to keep track of student data, we might have a GPA for a student. We'll have a name for a student. Maybe there could be other things, maybe like student ID. So we would create something like string student name, and maybe Chris would be the name. And we might have a int student ID, which could be 2, 3, 4, 5, 6. And maybe we would have a double GPA or double student GPA, which might be a 3.2. But what if we have more students? What if we have another student that we want to put in? Well, then we would have to do string student2 name equals, and we can probably say Joe. And we would have to keep creating 3 variables each time for each new student, the name, the ID, and the GPA. So how can we make this easier rather than having 3 names to store 1 person? Well, this is where objects come in. Objects are custom data types. So rather than having a separate string int double to represent 1 student, we can have all those 3 things in 1 class. So that's what this class means right here. So a class is going to be that collection of variables and methods. We can even have methods in classes. So how do we create, let's stick with the same example and say we want a student, a custom data type called student. So how would we do that? Well, we come over here and we would say we want a new Java class. And we want to call it student, so then we would have and everything else will be auto-filled for us. So we have a public class student. Now we can put our string name here. It's just a variable for now, so we don't assign it anything yet. We would have an int ID, and maybe we would have a double GPA. So now we can have a student type. In the main class, if we wanted to use it, we could say student C equals new student. So this is how we would create a student. Now, if we wanted to print out stuff, well, first we would have to assign student. So the C is the variable now, and new means we're creating a new student with the defaults for each of these, name, ID, GPA. So all of those are default. We have to save each of these files. So if we want to assign the values to the variables, then we do C dot, and then we can put GPA equals 3.2. We can put C dot name equals Chris, and we can put C dot ID equals 2, 3, 4, 5, 6. So now we have assigned the variable, and now we can print it out. So I'll do system.out.printf, and I'll just %.2f for the GPA. I will do a %s for the name, and a %d for the ID. And then let's put the variables. So same way, c.gpa, that's the first one. Then the next one is the string, which is c.name. And then the last one is the c.id, because that's the integer. And then we can save that and run it. And then we get the 3.20, since we rounded to 2 decimal places, we get the name and we get the ID. So this is how we can create a custom data type. Now, you might be thinking, well, we're still creating all of this, so there must be an easier way rather than having it done like this. Well, yes, there is. And this is where we get to something in objects. So C is the object. In this case, student is the class, because this is the class student. So student is the class and the object is the variable. So the variable is C. And then the dot is telling us what do we want inside the C. So C dot GPA means, okay, C over here, that's the variable. What is it? It's a student C. So student C dot means go inside and find GPA. So go inside and find GPA. So this, and we want to assign it to 3.2. So the next part we're going to talk about is how to assign it easier than writing it out in 3 separate lines. Can we just do this in one line when we create the new student? And yes, we can. And this is how we do it. We say student. We take the same name as the class name. And this is going to be kind of a special type of function because it is a function. So student, and we'll say we want to say string n. We want a string n for the name. We want an int I for the ID. And we want a double G for the GPA. And then we'll just say name equals n. We'll say ID equals I. And then we'll say GPA equals G. So this method here, student, allows us to assign the stuff that we pass into the constructor. So this is called a constructor. This special type of method is a constructor. So a constructor student, what does that look like in here? So this, the new is what constructs the student object, the C. New constructs it. So we have a red underline because right here it's blank. But now we can put it in the same order, string, int, double. So we put the string, so we put the name Chris, and then we put int, which is 2, 3, 4, 5, 6, and then we put 3.2 as the GPA. And then we can erase all of this, and now we have the constructor constructing the object C. So now we've just put it in one line, and if we save it and run it, we get the same output as before, 3.2 Chris and 2, 3, 4, 5, 6. So this just allows the construction of an object, which is why this method is called a constructor. And we can also do something called overloading a constructor. Overloading a constructor means, let's say we want everyone to start off with the same GPA. So maybe we just want the string name and the int ID. Everyone's going to have a different name and a different ID, but everyone's going to start off with the same GPA. So let's say we want student, and we want a string n, and we want int I for ID. So we create another constructor, but this time we only pass in 2 parameters instead of 3. And we'll put this time name equals n and ID equals I. And then we'll say everyone starts off with a GPA of 4.0. Now I'll call this other student, we'll say student. We'll call student CD, student D equals new student. And we'll say it's Joe, and the ID is 56789. So now we've created a new object D for Joe 56789, and we can print out the same thing. I'll copy paste this. And instead of C.GPA, we'll do D.GPA, the D.name, and the D.ID. So this will tell us that Joe starts off with a 4. So 4 is the GPA that comes first, then Joe, and then we have the student ID. And we could even do the same thing if we removed Chris, the GPA here, then we ran it again, we would see that even Chris has 4 GPA starting off, Joe, Chris, and then we have the IDs afterwards. So these are what constructors do. They make it easier to make our objects. They make it easier to construct. So this is constructing because it's building it at the time when you assign it. At the time of assignment, you've already given it the values, so it's constructing it. And this is called overloading, where you have the same method name, but you have a different number of parameters. And there's a red line underneath this student because we don't use 3, so let's bring this back to 3.2. And then we will see here that there is no longer a red line. Now, what if we want the name to be the same? Like, I want to pass in string name, and I want to pass in an int ID. Well, if we just say name equals name and ID equals ID, then we get some red underlines because we don't know which name it's talking about. Is it this name or this name? It's hard to tell. So if you want to have the same variable name, what you can do is say this dot name equals name and this dot ID equals ID. What this does is it's talking about the class it's in right now. We are in class student, so this dot name means this class's name, and then this name would mean the other name. And when we say this dot ID, we mean this class's ID. So we're talking about this one right here. And GPA here, since there's no GPA, we can just say GPA because there's only one GPA. But if we did this dot GPA, we could make it more clear that we're talking about this class's GPA, but this isn't required for the GPA, but it is required for the name and the ID. So we can reuse the same name, but we have to use this dot to tell we're talking about this class's variable name. And if we make those changes and run it, we should get the same results. Yeah, we get 3.2 Chris and the ID, and 4.0 Joe and the ID. These are the basics of classes, but we have an additional layer that we want when creating classes. So student is the class. We've talked about that. We've said C is the object. The object is just the variable of the class. And these are constructors because they construct the class at assignment with the new. So these are constructors, and the constructors in the class are defined here. These are the constructors that are doing the construction. But then we also have something in object-oriented programming. When we have objects and classes, that's called object-oriented programming. In object-oriented programming, there's a concept of data protection. We want to protect the data. And who do we want to protect it from? Well, we want to protect it from ourselves. We don't want to just say, like how before I was saying that I want C dot GPA equal to 2.0. We can't just have someone change the GPA like that. It's not protected. And why is it not protected? Because we can just go into the class and assign the GPA like this. We can make errors if we write code like this. Like right here, we can just access the GPA directly. So in data protection, we don't want to be able to directly access the name, the ID, or the GPA, because changing these would be very detrimental to the student. So how do we restrict access to variables like this? We restrict access by putting the word private in front. Private and private. Now if we save this, over here we get the error C.GPA. GPA has private access in student, so we can't write this anymore. So by doing private, we're protecting ourselves from making mistakes. If other people are looking at your code and someone says C.GPA or D.GPA, they won't be able to do that. You'll have to change it some other way. And even over here, C.GPA, C.name, all of these have red underlines because we directly accessed those values, but this is not protected. And in object-oriented, we want to protect ourselves and other people looking at our code from accessing the variables directly. So how do we work around this? Well, the workaround for this are something called setters and getters. A setter will set the variable and a getter will get the variable. So if we want to set a variable, let's start off with the setters. So we will have to create a method to set the variable. And methods usually are void return because we don't want to return anything when we set it. And we will say set name will be the name of the method. Set name is the name of the setter. And what do we want to set? Well, we want to set the name, so we'll pass in a string n. And this is our setter for our name variable. So set name, we pass in the n, it's a string, and then we'll just say name equals n. So this will be our setter for set name. And then we'll also have a getter called getName. So we'll have the name getName. We won't pass anything in it, but we want to get the name, so we want to return the name. The name is a string type, so we'll have the method be a string return. And in the method, we will just say return name. So the name is returned. Now, the void set name and the string get name, we want these to be accessed from outside of the class. So we'll actually call these public. We'll call these methods public. So what public tells us is that these can be accessed outside, whereas private over here says these cannot be accessed outside. So notice how name, it's used inside here, in here, and even here, and here, because we're still within the class. We're still in the class. So private just means I can use these anywhere inside, but right here, I'm not in the class anymore. I'm outside the class. So that's why we need public here. And these publics are going to allow us to get and set the name. And then we can do the same for ID and GPA. So we'll say public void set ID, and we'll get an int I. And then we'll say ID equals I. And same thing as the constructor here. If we want to pass in an ID, we can do that and just put this.id equals ID. We can do that over here as well. And same thing with the name. We could have done that with the name as well. If we pass in the name, then we can do this.name equals name. So this is the set ID, and then we'll have the get ID public, and ID is the type int, so we'll return int public int get ID, and we won't pass in anything, and we'll just return ID. And then the last one is the GPA. So public void set GPA, and we'll put a double G, and then we'll just say GPA equals G, and then public double get GPA. Nothing gets passed in, but we return the GPA. So we've created our setters and getters for each variable. I'll add in some lines to separate these out. So the first one is the setter and getter for the name. The second one is the setter and the getter for the ID. And then the third one is the setter and getter for the GPA. So we have our setters and getters, and for the constructors, we don't have to put anything because the default is just good enough. We can put public student and public student as well to specify that we want this to be accessed outside of the class. And then over here we have all these red underlines, so we'll just say get GPA instead of GPA. Over here we'll say get name with the parentheses, and over here we'll say get ID. And same thing for the other one. I'll just copy paste this into here, and rather than C, I'll put a D and a D and a D. So we've protected our data now, and if we run this, we should see the same output as before. And we do get the same output, 3.2 Chris with the ID and 4.0 Joe with the ID. So now we've protected our data using public and private. And these are the concepts of object-oriented programming. We have data protection, we have constructors that construct the object, and this is called overloading a constructor, meaning having the same name on the method but with a different number of parameters. And then we have the setters and getters that help with the data protection of private. And then we have public, which is another keyword used in data protection. So private means only within class student. Only inside this class student can we use the private variables. And public means these methods can be used outside of the class. So outside of this class student, like over here, we can use the public methods. So let's say we want to change Chris's GPA, or let's say we want to change Joe's GPA, because right here we have the default for Joe's GPA. Over here we set Chris's GPA to 3.2, but we didn't set Joe's GPA, so we use the constructor that would set the GPA to 4. So let's change Joe's GPA, and let's say that we want to do d.set GPA. And we want to set Joe's GPA to be the same as Chris, 3.2. Or let's say 3.4, so we know that we're getting Joe's GPA and not Chris's GPA. So if we do d.set GPA, and then we do a system.out.print f, and let's say we want %.2f to 2 decimal places, we'll do d.get GPA. So we're getting D, the object D's GPA. So get GPA should give us a 3.4 because we set D's GPA here. So when we run it, we should see an extra line that has 3.4 here. So these are how the setters and getters work. There are more concepts that we can talk about in object-oriented programming. We talked about the class, we talked about the private, we talked about the public, we talked about setters and getters in data protection. This is a pretty good introduction, and we talked about the reason for having objects. We talked about constructors and how we can have default values that get assigned, like over here GPA is 4. If we don't tell the GPA, then it automatically gets set to 4. And why do we have objects in the first place? Well, we have custom data types so that we don't have to say student 1 name, student 1 ID, student 1 GPA, student 2 name, student 2 ID, student 2 GPA, and so on and so forth. That's 6 variables for 2 students. Instead, we can just have 2 variables that are constructed using objects and constructors. So this is how objects and constructors and object-oriented programming allow us to make our code more simple rather than having multiple variables for the same thing. In the next video, we will keep talking about more concepts in object-oriented programming.